Okay, good morning, everyone. Today, I am here to explain one of the other important topic of artificial intelligence. It is called as matching and control knowledge. My name is Dr. M. Nagaraju, Assistant Professor, Department of Computer Science and Engineering, Artificial Intelligence and Machine Learning Department, Institute of Aeronautical Engineering, Hyderabad. So, matching and control knowledge. This is a continuation topic to our previous concept, which is called as forward reasoning and backward reasoning. If you are directly watching this video, you may not understand the topics actually. So I suggest you to watch the video of forward reasoning and backward reasoning, and then you can come back to understand this matching and control knowledges. So here, before moving into the topics, I want to cover two important topics during this session. One is called as matching, and another one is called as control knowledge. As I mentioned, that it is a continuation topic to the forward reasoning and backward reasoning. So our primary duty is we need to understand why we are taking this matching and control knowledge as a continuation topic. So let us try to recap some of the points of forward reasoning and backward reasoning. We have discussed some of the important points, like in the forward reasoning, mostly our primary duty is to find out to conduct a search activity. Means the search activity will be performed between 2 points, which is called as initial state, and another one is called as goal state. So our primary duty here, it will be to identify the path in between the initial state and goal state through searching. Means the forward reasoning and backward reasoning is mostly useful in order to identify the path through a search technique in between 2 points, which is called as initial state and goal state. Here the biggest question is, how can the AI agent, means how can AI program can shift from one state to another state, so that at the end it can reach to the goal state. That is an important point. Why? Because as we know that if you consider two important points, if you consider the 2 points like initial state and the goal state, so here in this case we cannot directly say that we are going to jump from the initial state to goal state. Okay, most of the cases, in most of the applications, it may not be possible. So what we have to do is, in between there will be some other points. We can say it is not points, it is some of the states. Means if you want to move from initial state to goal state, in between you have to reach to the other states also. Now the question is here, if you want to continue our search process to find out the path, then we have to repeatedly we have to go on changing our states until and unless we reach to the goal state. So what is a strategy that makes us to move from one state to another state? That is important. In the earlier sessions, we discussed that there is a point called as rules. Means when you are in a particular state, for example, think that you are in the initial state, you want to move towards to the other state. For example, this is the state you want to move, state 1. So what makes you to move from this state to this state means whenever you are applying the rules to this particular state, then if that rule is applicable, automatically it will make you to move to this particular place, that particular state. Means applying of rules to a particular state, maybe it is an initial state or maybe it is your current state. When you apply such rules, and if those rules are applicable to that particular state, then automatically it will make you to move to the next state. Like this, you have to keep on applying the rules until you reach to the goal state. So this is a general strategy we follow while working with forward reasoning. If it is a backward reasoning, the same strategy, but instead of moving from initial state to goal state, we move from the goal state to the initial state. Okay, so during this forward reasoning and backward reasoning, we insisted, or every time we stressed on the point that you have to keep on applying the rules. Select some rule, apply it to your current state, try to change to the next state. You keep on doing it until you reach the goal state. We restricted our explanation about those rules at that point only. But there are a lot of questions that comes into picture. What is those questions is our today's topic, which is called as matching and control knowledge. Just now I told that matching, it is a process of using the search to solve the problems. Okay, it is a process of searching the problems, and during that search, our primary duty is we need to identify the appropriate rules. Just simply identifying a rule, applying it to the current state will not make us to move to the next state. We have to be in a stage to identify that which rule is the most appropriate tool to that situation or to that state. Until and unless you select the perfect state, perfect rule, you cannot change your state. Even if you make the change in the state, it may not lead you to the goal state. Means identification of the rule is very important, and also the selection of the appropriate rule to that particular state is also very important. I'm repeating, you see, if you are selecting a wrong rule, means if you are applying a wrong rule to the particular state, then it will not make you to move towards the goal state. Your path may be to something else, some other point. So being a human or being a AI programs, its responsibility is, means the search technique responsibility is, it has to identify the appropriate rules from the given list of rules, and then it has to apply to change its state. So during this process, our primary duty is we need to identify the appropriate rules. And sometimes what happens, we need to apply the rules. We need to apply the rules to the individual states. Remember, rules cannot be applied for only once. So how many states you want to change, those number of times you need to keep on applying the rules. Means in the previous example, in the previous slide, I have shown one example there. You have to move towards 5 points to reach to the goal state. 4 or 5 points to reach to the goal state. Means 4 times you have to identify the appropriate rules, and 4 times you have to apply them to change your position. So this process, as I mentioned, that it is a continuous process until you reach to the goal state. Now the biggest question comes is how to extract suitable rules. How to extract suitable rules. Why? Because the rules, whenever I say that rule is not just a limited one. Means the count of rules are not limited. Just we cannot say that there are only 1 to 10 rules or there are 1 to 100 rules. There may be some 1,000 number of rules. When the 1,000 number of rules are there, our other primary responsibility is which rule is applicable to our search process. That is also very important. So here the main question comes is how to extract, how to identify a suitable rule to our particular state from the given list of rules. Of course, sometimes the list of rules will be given, or sometimes we have to generate ourselves. So in both cases, main thing is we need to identify or we need to extract a particular rule from a given list of rules, and we have to apply it to our current state. That will make us to move to the next state. Okay, so it is going to involve, what is that? It is choosing among the rules that can be applied at a particular point. So this question comes into a picture. And also how we are going to know that whenever we applied a particular rule, how is it going to make us to move towards the goal state or not? We cannot guarantee, right? Why? Because sometimes what happens, until and unless you apply the rule, and until and unless you see the result of that application, you cannot supposed to say that you are moving towards the goal state. So your primary duty is here. This one also comes into picture. Not the primary duty. We can say that some complications. The first complication is how we are going to identify a particular rule from a given list of rules, and how can we guarantee that? How can we confirm that the application of such rule is leading us to the solution? Okay, and how can we extract? That is also important. How can we extract the entire collection of rules that can be applied to a given point? See, applying of rules is very important. It is mandatory for every point, for every state to change your state. Okay, so in this case, how we are going to extract the rules? That is also important. Means you have to keep one point in mind that for a particular state, right, we cannot say that there is only one rule which can be applicable. It depends upon the application of our problem. Application means our problem. Means sometimes there will be some states where 1 or 2 rules may be applicable. But in some cases, there will be more than 2 or more than 5 applications. We cannot give the number, but there will be more number of rules which you have to select in order to apply to a particular state and move towards the other state. Means these are the different complications we are going to arise when we are trying to extract the suitable rules. And the answer for this one will be matching. Means the complications. If I simplifies the complications what we are raising in extracting the suitable rules, then we can say that the first one, how we are going to search, means how we are going to search for the appropriate rules. That is our first problem, right? And our second problem is how can we guarantee that the applied rule is going to make us to move towards the goal state. Okay, so these are the two complications what has arisen during this application, rules application. So the solution we are going to talk about is the matching. So what we have to do is every time we need to perform the matching. So what do you mean by matching here? Right? So let us try to understand. Matching is nothing but we can say that when you are doing the matching, it's a kind of comparison. So what we have to compare with what? See, generally we are talking about the rules. Whenever it is rules, so we have to talk. So what we are doing, we are applying these rules to a particular state. Maybe it is your current state or maybe it is your initial state. You are applying the rules to this particular state. So here what we are doing, what the solution we are thinking about now, it is a matching. So what we have to match, we need to match the rules. Rules with what? Rules with the preconditions. Rules with the preconditions means each and every state, okay, each and every state between the initial state and goal state, they are having some preconditions. Means every time we need to make a matching between the rules and the preconditions. When this matching is successful, then we can say that the selected rules are applicable to this current state. Then directly we can apply it and we can move to the next state. Okay, this may be our next state. Okay, here now once you move to the next state, then this will becomes your current state. So again what you have to do, you have to pick up the rules. You have to check for the preconditions for these rules. And you have to do the comparison, means mapping. And then if you found that these rules are applicable, then directly you apply it and move towards the next state again. This process is a continuous process. Means every time your primary duty is to perform the matching. So what you have to match? You have to match the current state and the preconditions of the rules. If they are matching, that means that they are the applicable rules to that particular state. Then simply you apply it and change your position. And one solution is given to us. What is that the solution? Means matching means during the time of matching, right? Even it is very difficult to search, means to perform the matching among the thousands of given list. Just now I mentioned that the rules are not limited. You are going to see some thousands of rules. In the thousands of rules, again doing a matching is also a very big problem. So we are trying to give some of the solutions, right? There are some of the solutions which can make us the matching process so easy. In that one, the first process is indexing. Okay, so during the time of indexing, what we do is we will try to perform the search through all the rules. We will perform the search through all the rules and we will try to make the comparison. Comparison with what? Comparison with the preconditions to the current state. So if our comparison is successful, then we are going to extract all the rules that are matching to the current state. Now the question is, how can we do the indexing? Okay, we will take one simple example and we will try to understand. Okay, the problems in this approach is also there, but before the problems, we will try to see some of the examples. Just now I told that these are the problems which are not related to the indexing, but in the form of matching. When you are trying to do the matching, what is that? It will be necessary to use a large number of rules. Why you require large number of rules? Remember, whenever you are having large number of rules, then it will makes us easy for the application. It will become very easy to apply it to the current states. Means the more rules you have, that much easy your search process will become. That much easy your navigation from one state to another state will becomes easy. Means before solving the problem itself, our primary duty is we need to frame up as many rules as we can. Once it is done, then next we have to go for the application. But at present, we cannot guarantee that whether the applied rule is making us to move towards the goal state or not. Okay, so these are the two problems which are arising in the concept of matching. So the solution just now I told that it is a indexing. Means if you want to overcome these kind of problems, means every time I don't want to search among the large given number of rules. I cannot guarantee that whenever I applied a particular rule, it is making us to move towards the goal state or not. So these two complications are there. Means we can say these two ambiguities. So in order to overcome these problems, better to have to implement the concept called as indexing. So what we have to do instead of performing the search. So why these two problems arise? Why? Because we are doing the search process. So instead of doing the search process through the rules, okay, why can't we have an index to all the rules? So instead of keeping the rules individual, better make them as indexed. Means it is also called as some kind of matching. Okay, means how we are matching with the index. So index between what? Index between the rules and the matching one. Okay, so in simple words, we can say that you need to perform the indexing to the given rules or to the preconditions of the rules. Means once it get indexed, then it will be very easy for us to identify which rules are applicable and which rules are not applicable. We will take one simple example. Okay, so let us think that you are working with a chess playing game. Okay, as we know that a chess playing game is a 8 by 8 matrix representation. The board is of 8 by 8. Means you are going to see 8 columns. Okay, you are going to see 8 columns and you are going to see 8 rows. Now the question is, first of all, we need to identify, okay, how many positions will be there. Means how many states will be there. Means whenever you are playing the game, the number of states will be the number of board positions here. The number of board positions. So it will be 8 by 8 board. Okay, so for 8 by 8, how many rules we have to generate? Means for that one, we need to understand how many number of legal moves we can perform in this 8 by 8 board. So the number of rules are 10 to the power of 120. So how many rules you have to frame? You have to frame 10 to the power of 120 rules. For example, think that I am in this particular state. This is my current state. I want to move towards other state, right? Okay, I want to move to the other state. So which rule I need to apply? So what I have to do? I need to perform the search among these 10 to the power of 120. But searching process is not at all possible in this case. So what we are doing? We are keeping the indexing of each and every board position. Or we can say we are going to keep the indexing of all the preconditions of the rules. Then it will becomes very easy to identify. Means whenever you found a particular rule is applicable to that state, immediately you select it and you apply it. That is the first concept we are telling. To access the appropriate rules, okay, immediately what you have to do, you need to assign the index to each board position. Means each and every board position is going to have some indexes. With the help of some hashing function, you try to make it as a key itself. The index as a key itself. So what happens? All the rules that describes a given board position will be stored under that key. And so it will be very easy to find. Means the indexes which are having the same key, they are going to find in the same place. So this concept will make us to identify the appropriate rules in a simple fashion. Means there will be no such complications which we have seen in the searching process. So we can say that indexing is making the complication of identifying the rules, reducing the complication of the rules to some extent. But there is a problem in this approach. What is that? See, we are generating the rules for chess playing game. Whenever I mention that it is a rules related to search, that means that we are talking about some specific rules. Means these rules cannot be applied to other problems. So whenever, if you are having another kind of problem, then again you have to create your own rules. So the same kind of process again you need to follow. Means one possible approach means or one simple approach which can make your search process easy is indexing. Means instead of performing the search activity, better to do the indexing of all the rules and try to connect them all together. And another approach, right? You try to do the matching. You try to perform the matching by comparing the variables. by comparing the variables. Here the question comes is, when we require these kind of things. Indexing, that is one criteria, means one situation, we can say one scenario. The other scenario here, we are doing the comparison. See, you need to keep one point in mind, that is our primary duty here in this case initially is to identify the rules which are applicable to our current position from the given list of rules. Whenever we find that, means whenever we are successful in identifying the appropriate rules, then we have to go on applying them. The strategies, means the first one I talked about indexing. So why we are using indexing? To identify such rules only. If you perform the indexing to the preconditions of the rules, then it will be very easy to select the rule or to identify the applicable rule. And next one is, the other approach we are saying is, you try to make the matching of the variables. You try to make the matching of the variables. So what happens is, here every time you have to go on the matching of many to many. Okay, so what happens is, many to many is going to be the more efficient one. So in this case, what we are doing, is we are trying to match, or we are trying to map, right, many rules, right, against many elements in the description simultaneously. Means we are not just mapping one variable with one element of the description, but we are taking multiple variables in the rule, and we are going to map it or match it. Okay, match it with the elements that are given in the description of the current state, or we can say initial state. So whenever such kind of matching occurs, that means that that rule is appropriate or applicable to that situation or that state. So in this case, what we are doing is, in order to make this many to many mapping, we are taking the help of one algorithm which is called as many to many match algorithm, RET. Okay, this algorithm is so efficient in doing these kind of mappings. So we can say that there are three possible reasons. There are three main reasons which is proving that RET is so efficient. Let us try to see what these reasons are. The first reason, it is concentrating on the temporal nature of the data. Here temporal nature means, generally what happens is, whenever you are applying some rules to the descriptions, right, there will be no change in the description. See, you try to understand, there is a particular state is there, you are in this current state, your current state is this one. To each and every current state, there will be some description, mean describing about the state. So what we are doing, we are trying to apply the rule. So whenever you apply the rule, that means that you are applying to the description itself. You are trying to make the mapping with the description itself. So during this case, what happens is, there will be no change in the description, remember. There will be no change in the description. Even if there are some changes, it's a minute one. Minute one means sometimes you may add one or two elements to the description, or sometimes you may delete one or two elements which are not necessary from the descriptions. But apart from that, there will be no change in the descriptions. Okay, so rules usually do not alter the state descriptions radically. Okay, if a rule did not match in the previous cycle, this is also very, very important. If any of the rule did not match in the previous cycle, then simply you can omit it. You can ignore it. For example, think that you are having 3 rules. So you came to know that the second rule, which is not applicable in the previous state, which is not applicable in the previous state, then simply in the next state also, no need to worry about this rule number 2. Simply you can ignore it. So next time what you do, instead of identifying among these 3, you are going to search only in these 2 rules. That is a meaning for this one. If a rule did not match in the previous cycle, it is almost likely failed to apply in the current cycle. But all these informations or all this process, we can say that the RET is going to maintain. A network of such rules or a network of such conditions RET is going to maintain. It is also going to determine which new rule might apply and which one may not applicable. Hence, we can say that it is some kind of a filtering process. Filtering process means separating the applicable rules and separating the non-applicable rules, so that our search process, means during the time of matching, our search process will become simple. Next reason is, structural similarity in the rules. Just now we mentioned that there will be multiple number of rules. There will be thousands of rules will be there. So in these thousands of rules, there will be some rules which are taking some structures in common, which will have some structures in common. For example, you see different rules may share different large number of preconditions. For example, you see there are two conditions, there are two states, right? For example, this is your initial state and this is your current state. After applying some appropriate rules, think that you have moved to the current state. So when you do it, whenever this current state preconditions is matching, then only you are applying the rule and you are moving to this position, current state. So think that there are some preconditions like 1, 2, 3. And for this state also there will be some preconditions. For example, the same preconditions 1, 2, 3, 4 and 5. So by seeing these numbers, we can come to know that there are some similarities. There are some similarities. What is that similarities? 1, 2, 3 and 1, 2, 3. So what happened in the earlier state only, you have already applied these states and you came to the next state. So what do you mean by this? The preconditions of this state and the preconditions of this state are having some common similarities, common structures. So in this case, it's not necessary to apply these. So it's not necessary to apply these three. Only you can apply or you can make a matching of 4 and 5. Means before applying the rule, you can check only for these preconditions, 4 and 5 preconditions. No need to check the preconditions 1, 2, 3. Why? Because you have already checked those preconditions in the earlier state. Okay. So if we match the two rules independently, then again it's not necessary to do the comparison. Just you ignore the preconditions which you have already applied in the previous state. So how to come to know that? Means RETI is going to maintain all such kind of information. Means before applying or before performing the search or before performing the matching of the rules and the preconditions of the rules and the current state descriptions, your primary duty is you need to refer to RETI. Okay. And the third one is persistence of variables binding consistency. So in this case, what happens is, while all the individual preconditions of the rules might be met, there may be some variables binding conflict that prevent the rule from firing. So just now we discussed that the preconditions of the rules and the description of the current state is matching, then we are applying the rule. But in some cases, what happens is the descriptions will match, but the variables present in that description may not match with the variables present in the rules. So even the variables are not matching and other descriptions or preconditions are matching, still also you cannot apply the rule. For example, think that we are talking about a precondition saying it as D is a dog. Okay, sorry, D is a dog. Okay, think that in your rule, instead of D, you are having something. Instead of D, it is having some Tommy is a dog. So this is just an example. It is not a rule, but I'm giving just an example how these variables may not match. So here what happened in this case, I'm talking about Tommy, but in the preconditions it is mentioned as D. So what happens here? There is a conflict in between the variables. So in this case also you should not supposed to apply the rules. Okay, it is just an example to make you understand the conflict. Right, but actually in rules the sentences will not be that much simple. We will try to take the example. So what is the example here we are having? See, we are talking about a predicate son. Who is son? Mary. Okay, Mary is a son of some Joe, or Joe is a son of Mary. Okay, it is up to you how you represent it. Similar to that one here, this is. So what we are doing, we are generating some individual precondition to the rule. So what is that? From the existing rules, or we can say from the existing preconditions, we have generated one more. So in this case, what happened? Instead of son, we are talking about grandparent. We are talking about grandparent, and sometimes we may represent X, sometimes we may represent as D. So even in this case also there will be a conflict, means even the descriptions and the preconditions of the rules also matching. If there is any conflict in between the variables, means if the variables are not matching, then also it will stop the rule to apply. Next, the complexity and approximate matching or appropriate matching. Sorry, appropriate matching. So what happens here? You see, a more complex matching process is required when the preconditions of the rule specify required properties that are not stated explicitly in the description of the current state. So what do you mean by this? There is a description. Okay, I'm trying to give the explanation for this one. You see, there is a description and there is also some preconditions. In some cases, what happens is, in the descriptions, some of the descriptions, it will make us to generate new knowledge from the existing knowledge. But actually what happens, the preconditions of the rules are framed exactly based upon the descriptions given. But sometimes what happens in the real-time scenarios, the description may lead to other knowledge. It may lead to other knowledge. But here what happens, if the new knowledge is generated, that new knowledge you cannot do a matching with the preconditions of the rules. Why? Because preconditions of the rules are strictly related with the descriptions of the current states. But here what happened, unfortunately, the given description are making us to generate new knowledge. So in this case, we can say that we are going to see some kind of complexity. So what we have to do in this, in its simplest form, matching is just the process of comparing two structures or patterns for equality. Matching, what we are doing the matching between the preconditions of the rules and the description of the current state. So just the search technique is going to see whether the given structures and whether the given some kind of patterns are equal or not, means are they are same or not. If any of the case it is not same, if the match is failing, then we can say that we cannot apply such rules. We will try to take one simple example and we will understand. Okay, we are seeing an example related to two character strings. How it will be, you see. There are two characters in the two strings in this, right? A, C, D, E, B, F, B, A, and another one is the same, similar to this one, A, C, D, E, B, E, and B, E. You try to observe, in this position, the character is F, but here it is E. That is the only difference between these two strings, and remaining things are same. Now the question is, can I apply these kind of things to a specific state, or to a current state? So you should not supposed to apply. Just now we discussed that here the matching process is nothing but comparing the two given structures. Comparing to the given structures are the patterns. Whenever there is an exact match, then only we can apply it. But here what is happening, we found some difference in between these two things. Only one character is difference, right? But still you cannot apply this to a current state. So what happens here? We are failing on exact match. Why? Because in the sixth character position, there is a difference. We will see one more example. So in this case, what happened? We are taking a specific variable, which is called as question mark x. So what is our expression? This is our expression. So what I have done is, by taking the help of this question mark and x, I have replaced this CD. I am replacing this CD with question mark and x. So our new representation will becomes like this. But in this example, what happened here, you see, our given expression is this one, right? And I am using question mark x for two cases. For two cases means, one case question mark and x, I am using it for CD. In the other case, question mark x I am using to represent f. Here still there is a conflict. What is that conflict? You should not supposed to use same variable for different representations or different replacements of the values or the constants. So in this case, what happened? Question mark and x I am using to replace CD and replace f. But this should not supposed to do. It should not supposed to happen. Means even in this case also, you should not apply the rule. So the conflict resolution. The conflict resolution means, in this case, what happens, you see, the result of the matching process is a list of some rules whose antecedents have matched the current state description along with the binding variables. Okay, means along with variables, means the description should match with the preconditions of the rules. Also, the variables also need to match. Okay, the conflict, how the conflict will come, you see. So it is a job of the search method to decide on the order in which the rule will be applied. Conflict means which rule need to be applied at what time. For example, think that there are some n number of rules to you. N number of rules are given to you. Okay, so this what I have done, I think by doing some indexing kind of thing, or by doing a matching of variables. Okay, and all these things what you have done, you could able to filter. We can say we could able to filter some rules. For example, think that at the end we have filtered only 5 rules. That means that these 5 rules are the only rules which are applicable to our process. So the question comes is, so which rule I need to apply first? Okay, anyhow we could able to filter the rules from the given list of rules, but the thing is, how can we apply? Here, this 1, 2, 3 does not mean that they are in particular order. Only for our understanding, I am representing these things. But in real case, there will be some rules, just rule. Okay, rule like that. So there are 5 rules. Think that there are 5 rules. Now the question comes is, which rule I need to apply at what time? Okay, means the order of the rules applicable is also very, very important. Means in this particular case also some conflict is going to come. So what we have to do is, we need to resolve that conflict. We need to resolve the conflict. So here, incorporating some decision making into the search process, generally we call that it is a conflict resolution. So there are 3 basic approaches how we can overcome the problem of conflicts. Okay, nothing but 3 approaches to resolve the conflicts. Means the order. So here we are talking about the preferences based on the rules. So what is the first thing we are having? We need to specify the physical order of the rules. We need to apply, or we need to specify the physical order of the rules, and we have to give the preference. We have to give the preference to the rules which are appearing first, which are applying first. For example, R, okay, P, Q, R, S, T are the rules. Let us think that. So in the given list, which one is appearing first? P is appearing first. So what I have to do is, I need to give the first priority to P. Why? Because the physical order is P is appearing first. Okay, that's why we need to give the priority to the first one which is appearing physically first. So what we have to do is, we need to build up a matcher. We need to build up a matcher so that it rejects the rules that are more general, and the remaining things will kept like that. Means here we are going to identify the rules which are too general. Then if such kind of rules are there, then we are going to remove those rules. We are going to see the rules which are too specific to our thing. See, if the set of preconditions of one rule contains the preconditions of the another, so simply you need to ignore the one which is more general. If the preconditions of the rules are the same as those another, except in the first case variables. Except in the first case variable, there are some variation in between these two.
Comes.
Sorry for
display,
this.
and they can capture all those things and
Camera is continuously.
like this is like 3 warehouse studios.
2 more studios are there, sir. Parallelly they are running. So after
So every day 10 hours nearby 8 to 10
but
hours.
can't it make an interactive?
It is one of the interactive mode. Is there.
One more studio. Interactive.
Student number 3.
Oh, completely not ready.
Thank you. Sorry for
Okay, sir.
Everything is matching field itself. 5,000 videos you have up to now.
Okay, if the set of preconditions of one rule contains the preconditions of the another, then simply ignore the one which is too general. Okay, and if the preconditions of the one rules are the same as those of others, except that in the first case variables. So what you have to do is you need to identify. Means after our identification, you came to know that in the first case it is in the rule it is represented with the variables, and in the other case it is represented with constants. So in that case, means if the preconditions of one rule are the same as those of another, except in the first case variables are specified, where in the second case there are constants, so simply we can ignore the first one. Why? Because just now I mentioned that the rule which is too general, simply you have to ignore it. Means whenever we mention the variables, that means that it is a general rule. Okay, so you have to ignore those rules and you need to select only the second one. And preferences based on the objects. Okay, so the matching process can ease the burden on the search mechanisms is to order the matches if finds based on the importance of the objects that are matched. Even the order of the objects and also its importance also matters during the application. So the patterns look to for specific combinations of important keywords. Means in this process we are going to identify or we are going to select some keywords. Means in this case the matching will be done in between the keywords, and we are going to we are going to give the rules whose matching involves the higher priority keywords. Means identification of keywords, giving the priority to those keywords, and try to do the matching of those priority keywords. When the most given priority objects are matching, then you can select that particular rule. And preferences based on the states. So fire, you have to fire. Fire means you need to apply all the rules that are waiting temporarily and examine the results. Means in this case what we are doing is we are not applying the rule individually, but rather we are applying the rules, all the rules together at the same time. Of course it is a temporary process. So once we apply it, then we are going to examine the results. Okay, we are going to examine the results, right? The one means the result which is making you to move towards the goal state, you have to select that one, and remaining rules you can simply ignore. I am repeating once again, you see, in this particular case, preferences based on the states, we are going to apply all the rules at the same time. It's a temporary process. Then we are going to observe the results. If any of the result is appropriate to you, means suitable to your problem statement, you select only that particular result, and remaining results you can simply ignore it. You can remove it, or otherwise you can keep it for further purpose also. And throw the remaining one or keep for later use. Okay, so that is all about the matching of the preconditions of the rules with the descriptions given. Once the matching is successful, then we are going to apply the rules to the state, and we will try to move to the other state. And the other important topic here is control knowledge. The knowledge about which paths are most likely to lead quickly to the goal state is often also called as search control knowledge. See, just identifying or just performing the search between the initial state and goal state is not the matter. So our primary thing is we need to identify the path. The question comes is, after applying the rules, there will be chances for multiple paths. So which path is making us towards the goal state, that is also very, very important. Why? Because you should not supposed to select the paths which are not making you to move towards the goal state. You have to select only the path which is making you to move towards the goal state. So how can we decide? How can we know that the rules are making, means the application of rules are making us to move towards the goal state? So for that one also you need to collect, or we need to acquire more knowledge. So the process of collecting such knowledge is nothing but here search control knowledge. So there are many forms given to us. The first one is knowledge about which states are more preferable to others. And the second one is knowledge about which rule to apply in a given situation. Knowledge about the order in which to pursue sub-goals. And finally, knowledge about useful sequences of rules to apply. Means we need to acquire, means before coming to a conclusion, we need to acquire more knowledge about the states and the preferable things to others. And we need to get the knowledge about the application of rules. We need to know the knowledge about the order in which the rules need to be applied and how our sub-goals can be achieved. Okay, moving from one state to another state itself is a sub-goal. It is not the main goal. Our main goal is to reach to the goal state. And along with these three things, we need to get the knowledge of the useful sequences of the rules. Means the order how we have to apply the rules. In these four cases, what we are doing, we are concentrating on the acquiring of knowledge. So simply we can say that we are acquiring the knowledge about the knowledge. So knowledge about the knowledge, then we can say that it is a meta knowledge. So by the help of this meta knowledge, we are going to do or we are going to perform an activity to identify that whether the path, the generating path is making us to move towards the goal state or not. So it is clear that we are discussing how the knowledge representation will be there. That is, we are calling it as meta knowledge. So for this one, we are taking the help of two AI systems, which is called as SOAR, and another one is Prodigy. So it is going to present their control knowledge with the rules. Now we can say that the SOAR is a general architecture for building the intelligent systems. Prodigy is a general purpose problem solving system that incorporates several different learning mechanisms. So in this case, what happens? The set of control rules are going to generate automatically. The set of rules will be generated automatically, which will make us to improve the search process in a particular domain. So how it is going to acquire the rules or generate the rules automatically means there will be the first one is coding by the programmers. The second one is statistical analysis. We can say statistical analysis of the domain operators, looking at traces of its own problem solving behavior. These are the three mechanisms through which the AI system is going to generate the rules automatically. In this, if you make a comparison in between these two AI systems, we can say that Prodigy, it is going to learn from its experience. It is going to learn from experiences. Means we can say that it is going to acquire more knowledge after the successful application of the appropriate rules. But it is not the case in the SOAR. Even SOAR is going to get some additional knowledge, or it is going to acquire some additional knowledge even through its failures also. So it will then use the explanation to build the control knowledge that will help us to avoid the fruitless search paths in the future. Fruitless search process means the path which is not making us to move towards the goal state. So this kind of things, it will make us to simply eliminate the paths which are not making us towards the goal state. Search control knowledge. We can say that search control knowledge can also tell us something about the order. Even the application, order of the application of rules also very, very important. So that is also going to provide us here by the search control knowledge. Okay, means we can say that this process, the search control knowledge process is a collection of knowledge about the knowledge. So that's why we say that it is a search control knowledge. It contains some meta knowledge. This knowledge will makes us, or it will helps us in identifying the appropriate rules, in identifying the order of the rules we need to apply, and also in identifying the paths which are not making us to move towards the goal state, so that you can ignore them and you can use only the path which is making us to move towards the goal state. Okay, so this is all about the concepts of matching and control knowledge, and this is the reference I have used. And in the next section, we will try to come up with a concept called as artificial intelligence search techniques. Till then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.